Dear sirs and mesdames, good day. Let me introduce myself. My name is Andriavelonera Anselme, researcher on the laboratory for mathematical and computer applied to the development systems. I am a PhD student in the University of Fianarantsoa, Madagascar. I am going to introduce you to the optimization of big data loading on the web with Elasticsearch engine. Our presentation will focus on big data. To start, let's jump into 2 Earth of the matter and present the context. For our 2.5 trillion bytes of raw data error, structured or unstructured. According to IBM's 2014 annual report. In 2020, the estimation raises to more than 40 zettabytes in the space of 6 years. In our time, the explosion of data on the web has not stopped due to the most popular social networks as YouTube, Facebook, Instagram, and Snapchat. Now that we have taken a look at our areas of research, here are a few of them. Ratna Nayaksi's 2010 works on Splunk for big data analytics. This work is of interest to us because it exploited Splunk to optimize semi-structured database management, to index and analyze massive data sets. The limitation of this work is that Splunk is a paid tool. Current to spend this work in 2022, we are interested in this work because it concerns big data and the ULK stock is part of it. The key points and advantages of this work are that using the Elasticsearch engine, the index return speed is very fast. Current despite work in 2022, we are interested there are also many advantages to this work. Detection of violent hazards within social networks. In 2022, we have optimized data mining. We have exploited the high availability of a server, the configuration and the development of real-time search. For technique is of great interest, although the limitation of this work is for manually configuration to the all parameters. We also enjoy a number of benefits from this org. IoT data visualization for business intelligence in corporate finance. Also is for Elasticsearch. Also is Elasticsearch. Also is the Elasticsearch tool for data explosion and visualization. The most effective is of the IoT framework management to analyze the multiple data sources. The limitation of this org, the search server is not optimized. It has a latency responses time. In the research and information visualization on the web, firstly, the user sends her information request to internet via the HTTP query. Then the navigator transfers the query to the search engine. The latter affects the treatment and the data indexing to the server. Finally, the server sends back this response to the requester. The summary of search engines, Splunk, Relog, Elasticsearch. All three use the same indexing method except Relog, which is limited. Relog is designed from the outside for log management. However, Relog and Elasticsearch are both open source search engines, while Splunk is a paid tool. In this context, the objective will be to optimize the processing of big data. In terms of performance, it is difficult to obtain satisfactory results when loading the big data. The complication of instant reading of several files on the web, the internet users have a difficulty consulting large files in real time. It is difficult to find useful information in a large volume of data. The contour of the problem takes shape. How can we harness the environmental power of the Elasticsearch engine for processing data? With regards to the problem raised, here are a few solutions. Firstly, design a high volume processing environment based on the Elasticsearch tool. Automate the design of distributed cluster management to make the tool easier to use. Increase the speed of responses performance and control the processing of large files with Elasticsearch. Controlling the processing of large files with Elasticsearch, we need to model a system to optimize the reading large of files on the web. The overall architecture of your approach is illustrated by this figure. To make good use of the power on search operation in Elasticsearch, we will combine it with existing relational databases. In these cases, we will probably need to ensure the Elasticsearch stays in sync with the data stored. Next, we will both Logstash and Symfony to efficiently compile records and synchronize updates from our database into Elasticsearch. We have several databases of different structures inherited with a large data set. We want to do real-time analysis and search of this data on your application developed with Symfony. We have to choose to use Elasticsearch to do the analysis and visualization in real time. To use the ULK stock, we must first migrate the existing data on MySQL to Elasticsearch before doing any processing. As part of the optimization, the first aspect is optimizing the processing time for big data. In other words, before loading data into the search engine, we first have to collect and process it. And this step can take a long time depending on the type of data we are trying to access. We are proposing ways of optimizing these periods and reducing the loading time at the reading. The second will be to exploit the ULK stock to optimize the interrogation and indexing of the data stored in the database. We used Logstash and the JDBC import plugin to synchronize Elasticsearch with MySQL. The MySQL documents are written to Elasticsearch so that they can be indexed. Next, the web application we developed optimize the data exploration and visualization in Kibana. The data search, analysis, and loading are optimized by the architecture. The following results are firstly, first access to data. The content of a document last consulted by users are automatically indexed. This reduces the number of data reading and consequently increases the responses of research results. Next, handling high amounts of data compared to a traditional SQL. The database management system that take more than 10 seconds to retrieve the required query data. Elasticsearch can do it in microseconds, 10 to be exact. And the Elasticsearch engine has a distributed architecture. It can manage a many server in parallel and the petabytes of data. The user have not difficult with managing the complexity of the distributed database management system. This is done automatically. In the minor results, the optimization of number of queries made to retrieve data. Finally, the cache are simplified by the using cache server. In conclusion, the data processing at the core of MySQL database lacked optimization to retrieve big data. It was decided that synchronizing this tool with the UNK stock for optimization the big data loading on the web. Implementing the two different database tools enables us to manage and monitor the loading of data into the log stage pipeline at the same time, and give us more advantages in terms of search engine reach times. The synchronization consumes a lot of hardware resources. In the perspectives, we intend to continue this work with the management of database storage services. Here is the end of your presentation. We are not used to speak in English, so could you excuse for some bad pronunciation? Thank you for your time and attention.